Artificial neural networks, ANNs, are computational models inspired by the structure and functioning of biological neural networks, such as the human brain. ANNs are a fundamental component of deep learning and are used to learn and model complex relationships in data. ANNs consist of interconnected nodes, known as artificial neurons or units, organized into layers. The neurons receive input signals, perform computations, and produce an output signal, which is then passed on to the next layer. The connections between neurons are characterized by weights that determine the strength of the signal transmission. The basic building block of an artificial neuron is the perceptron, which takes a set of input values, multiplies them by the corresponding weights, and applies an activation function to compute the output. The activation function introduces nonlinearity, allowing the network to learn complex patterns and make nonlinear decisions. An example of an ANN architecture is the feed-forward neural network. In this type of network, the information flows in one direction, from the input layer through the hidden layers to the output layer. Each layer of neurons performs computations on the received inputs and passes the output to the next layer. Feed-forward neural networks are widely used for tasks such as image and speech recognition, natural language processing, and regression. Another important type of ANN is the recurrent neural network, RNN. Unlike feed-forward networks, RNNs have connections that form loops, allowing information to be passed from previous steps to the current step. This recurrent nature makes RNNs suitable for sequential data, such as time series or sentences. RNNs have been successful in tasks like language modeling, machine translation, and speech recognition. ANNs learn through a process called training, where they adjust the weights and biases of the neurons based on the observed input-output pairs. This process involves forward propagation, where the input is passed through the network, and backward propagation, or backpropagation, where the error between the predicted output and the true output is used to update the weights through gradient descent. ANNs have several advantages. They can learn from large amounts of data, adapt to complex patterns, and make predictions on new, unseen inputs. They are capable of generalizing from the training data to perform well on new examples. Additionally, ANNs are tolerant to noisy data and can handle high-dimensional inputs. However, ANNs also have limitations. They require a significant amount of training data and computational resources. The architecture and hyperparameter selection can greatly impact performance, and overfitting can occur if the model becomes too complex or lacks regularization techniques. Interpreting the decisions made by ANNs can be challenging due to their black box nature.
The global artificial intelligence governance market is on the brink of explosive growth, set to soar from $890 million in 2025 to an astonishing $5.7 billion by 2029. That's an unmatched annual growth rate of over 45%, making AI governance the gold rush profession of the decade. This isn't just a career opportunity. It's your chance to become a credible, strategic human in the loop, shaping how artificial intelligence, law, and ethics converge to impact our world. Don't get left behind. Visit lawtificialintegrity.ai and claim your place in the AI governance revolution.
In conclusion, artificial neural networks, ANNs, are computational models inspired by the structure and functioning of biological neural networks. They have become a central tool in deep learning, enabling the learning and modeling of complex relationships in data. ANN architectures such as feed-forward and recurrent networks have demonstrated their effectiveness in a wide range of tasks. While ANNs have their limitations, they offer powerful capabilities for pattern recognition, prediction, and decision-making.
Please hit like, leave comments, share and subscribe to Lawtificial Integrity. We want the YouTube algorithm to absolutely love us. Explore the future at lawtificialintegrity.ai. Because artificial intelligence needs human integrity,